So we're getting ready to start our chapter on magnetism. And the first thing that we're going to study is magnetic fields. And magnetic fields are the region around a magnet where the magnetic forces are acting. And they're going to exert a force on other magnets and magnetic objects. Magnetic poles. This is where the magnetic force is the strongest. All magnets have a north and a south pole. And you can see the three different kinds of magnets pictured here. You can see a bar magnet, you can see horseshoe magnets, and you can see disc magnets. Now, magnets have interactions, and north and south poles are going to interact by attracting each other. Just like we learned with electricity, opposites attract, same thing in magnets. And then, so as you can imagine, like poles are going to repel each other. So the south and south poles of magnets will repel each other, and the north and north poles are going to repel each other. So we're going to look at this demonstration, and we're going to do this in class on Friday as a lab. But so we have two bar magnets here, and you can see that the two south poles have been brought together. And what has happened is they've sprinkled iron filings and so that you can see the lines of the magnetic fields. And you can see the lines are going away from each other, showing that they are being repelled. So if I change this one to north, now you have opposite poles, so they're attracted. So you can see the lines are now lining up, kind of showing that the field is going attracted to each other. So the Earth has a magnetic field, and the Earth is like one big giant bar magnet. The north magnetic pole of our bar magnet is currently located in the geographic south pole, so where our south pole is that we would normally think. And then so the geographic north pole is where our magnetic south pole is. So you may have heard that the magnetic poles can switch, and that does happen. No one really knows why that happens, but they can do research, and throughout the rocks over history, it has been shown that the magnetic poles have changed over 150 times in the past 70 million years. Okay, so magnetic domains, this is where all atoms have like a tiny little north and south in them. And like you can see that in this picture. Here's just a blown up picture of a nail. So all these are little atoms, and there's a little tiny north and a little tiny south. In most materials, these domains are just randomly arranged, and there's no pattern to them. Now, what makes a magnet is when all these tiny domains are lined up, north-south, north-south, and then that iron will start to have magnetic properties. Permanent magnets can be made out of magnetic materials such as iron. They're made by placing the material in a strong magnetic field, and that causes those domains we just talked about to line up. A permanent magnet can lose its magnetism if it's heated to very high temperatures. That will cause those domains to become unaligned because they have too much kinetic energy. Or like if they're dropped a whole bunch, then they can become scattered and lose their magnetic properties. So one question that you might have is, can one pole be isolated? Can you just have a magnet with a north pole or just a south pole? And the answer to that question would be no, because every time you break that bar magnet or any type of magnet, it's going to create a new north and south pole. Just like we saw in those domains, even if you had one tiny little atom, it would still have a north and a south pole. Okay, so